Hi everyone, I'm recording this short video to show the role trigonometry can play in urban planning and designing, particularly when it comes to historical parts of the cities. Through an example in Qom, one of Iran's historical cities, I try to show how the height of a new building can negatively affect a landscape in a historical building. To shed light on that, the picture is taken from the south side of Qom Jame Mosque Yard toward the north side, which is called Shabestan, where Muslims gather to pray at least 3 times a day. As you can see in this picture, there is a building that interrupts the skyline of Jame Mosque North facade. Uh, and as you can see, whether we believe that it can be against conservational regulations dominating historical buildings or not, so there is no reason to prove what happened in this part of the, one of the, historical neighborhood in Qom. Imagine this picture without that interrupting construction like this. So I think it's better. Nevertheless, the question is what the logical and reasonable distance between Jama Mosque and those buildings with, for example, 7.5 or 10 meters height. And this is where trigonometry is a call to action. Based on this area of mathematics, if we set the observer's location at one end of Jama Mosque Yard, they should see another end without interruption. I hope you agree with me. It means if we draw a line between the observer's eyes and the top line of the opposite wall and continue that line forward, there shouldn't be a building whose height touch over that hypothetical line. So we have a main triangle and some subtriangles, and we can estimate some dimensions in these triangles. We have some of the dimensions such as the observer's height, in average the height of the wall, and also that 7.5 or 10 meters, okay? So what we want to estimate is the length of the line X. Am I right? Yes, X, which shows us the distance between the Jama Mosque and neighboring buildings with at most 7.5 or 10 or whatever you want meters height. These calculations are based on similarity among triangles in this figure. So as you see them, the ideal distance between the wall and that hypothetical building must be almost 50 meters. It means from the south front of Jama Mosque to about 55 yards northwards, we can't construct a building with more than 7.5 meters height. So here we go. This is one aspect through which we can find buffer zones for historical buildings. Although there are many factors contributing to drawing buffer zones, these calculations could be an initial estimation to suggest those, lines. And you can, as you can see, there is a comparison between what I draw and the and the real buffer zones that you can find in their document. This one is my rectangle, and this one is the buffer zone. Okay, thank you very much and have a nice day.